guys, hopefully you've come here from my SOHCAHTOA video. If not, it might be worth checking that out before watching this. So here we're going to be using SOHCAHTOA to find the size of angles inside of right angled triangles. So, the buttons we're going to need on our calculator, we're going to need the three amigos, the three trig buttons, sine, cos and tan, and we're also going to need the shift button, which you should probably find the top left of your calculator. Now then, the three amigos, the three trigonometry functions are indeed what we call functions. Now, when we come across sine theta, that does not mean sine times theta, it means sine of theta. So sine, or all three of the trig functions, are actually quite messy and quite scary looking. What's going on is that theta is some number that's being plugged into these quite complicated functions. But you don't need to worry about that, your calculator takes care of all of that. So the reason that we need the shift button is that if we first of all press shift and then one of the trig buttons, it will bring us up what's called the inverse function of that trig function. So if we press shift and the sine, then we get a little sine to the -1 with an open bracket, and that just means the inverse sine. Now how an inverse function works is whatever number we put into that bracket after the sine to the -1, whatever number we put into that, we are asking our calculator what value of theta then, what size of angle will give sine of theta to be that number. Probably make more sense if we go through some examples, so that's exactly what we're going to do. Okay, so then, I've got our little game plan at the right. Don't look at the bottom picture yet, because that's the answer. We need to work out how to get there. So my very first step when playing trigonometry, especially while you're new to it, would be to label the sides of the triangle, but only really bother labelling the sides that we're playing with. So if we've got theta down in the bottom right angle, the 4 centimetre side is going to be the opposite, and the 9 centimetre side is going to be the hypotenuse. Now you can label the one along the bottom, it would be the adjacent, but we don't need to, it's no use to us. So we've labelled our sides. Next we go to SOHCAHTOA. Alright, SOHCAHTOA's time to shine. So we go through SOHCAHTOA and work out which part of it we're using. So S-O-H. We are indeed using SO then, because we've got the opposite and the hypotenuse. That tells us this is a sine problem. So, sine of theta is equal to the opposite over the hypotenuse. Therefore, sine of theta is equal to, now if we plonk our numbers in, the opposite is 4, and the hypotenuse is 9. So sine of theta is 4/9. And then finally we turn to our calculator and take the inverse sine of 4/9. So now we can look at this picture in the bottom right. We take the inverse sine of 4/9, press equals, and that will give us our angle of 26.39 degrees. If we go to 2 decimal places, be very careful with what degree of accuracy questions want. Trigonometry is a very common sort of question to get asked on your decimal places and significant figures, so just be aware. Okay, let's have a look at another one. So again, label the sides. So this 5 on the bottom will be the adjacent, and the 7 will be the hypotenuse. Let's go to SOHCAHTOA. So, it's not O and H, K, C-A-H, it's K then, because we've got the adjacent and the hypotenuse. So K tells us cos of theta is equal to the adjacent divided by the hypotenuse. So cos of theta, plonking our numbers in, here will be equal to 5 divided by 7. So then we go to our calculator and we put the inverse cos of 5/7 and we get 44.42 degrees, again if we're going to 2 decimal places. Okay, Example 3. So label our sides. So the 5 over here on the left is going to be the opposite, and the 3 down here is going to be the adjacent. Now, so, no, ka, no, toa, T-O-A, it's toa then, it's tan. So toa tells us that tan theta is equal to the opposite over the adjacent. So here then, tan of theta is equal to 5 over 3. So then we go to our calculator and take the inverse tan of 5/3, which would just give us 59.04 degrees to 2 decimal places. Okay, now then we're going to change the position of the angle. So this time our angles are going to be up in the top left, so it's going to switch around a little bit, and we're going to be playing with decimal places. So step 1, let's label the sides of our triangle. So there's 3.7 at the side is going to be the adjacent, and the 7.8 is going to be the hypotenuse. So no, ka, yes. So it's cos. So we know that cos theta is equal to the adjacent over the hypotenuse. So here cos theta is going to equal 3.7 divided by 7.8. Now, as before, we turn to our calculator, take the inverse cos of that, and here we would get 61.68 degrees. Okay, example 5. So, label our sides. So the 6.5 here would be the adjacent, and the 12.1 is going to be the opposite. So, no, ka, no, toa, yes indeedy. So toa tells us tan of theta is equal to the opposite divided by the adjacent. So here tan of theta is equal to 12.1 divided by 6.5. We turn to our calculator, take the inverse tan of 12.1 over 6.5, and we would get 61.76 degrees to 2 decimal places. Okay, one more. So, label our sides. So we got the opposite down here, and we got the hypotenuse up here. So, yes it is, SOH. So again, so tells us sine theta is equal to the opposite divided by the hypotenuse. So here, sine theta is equal to 2.3 divided by 9.4. So we take the inverse sine of 2.3 over 9.4, and we get 14.16 degrees. Okay guys, I hope that is useful. Look out for the next video, which is going to be on finding a side length using trigonometry, and don't forget to subscribe. Cheers guys.